So the equation here, which is 3x squared minus 5x plus 4 equals 0, and it has two roots, yeah? Alpha and beta. So what this means, guys, is that if these were just regular numbers like, I don't know, 2 and 3 or 1 and 4, etc., this means that if you factorize this, you get two solutions. The two solutions they use are roots, okay? Now, without solving this equation, form a quadratic equation with integer coefficients. In other words, keep it all in whole numbers, yeah? Your quadratic equation that has roots of these two quantities. Alright, cool. Now, let's take this step at a time, yeah? So on the first line, it tells us that this quadratic equation has these two roots. So what that means, yeah, and without solving this equation, we can say that if we somehow factorize this, yeah, if we work backwards, you would ask yourself, firstly, what two numbers do we need to multiply to get a 4? Okay, in this case, we need to use alpha and beta. Let's write this here. To get a 4, so to get your constant C, we need alpha times beta, yes, alpha beta. However, when you have like a quadratic equation where the value of a, the coefficient of an x squared is not 1, so in this case it's 3, you got to multiply one of these two values by 3. So it'll be 3 times alpha beta, and this is supposed to equal 4. So that's one equation. Now the second one we also need to find is usually the middle part, the b term. And we say, okay, if we got our two roots, if we add up these two roots, it should equal that. But because you got, again, 3 here, you got to multiply them. So we can say, alright, to get, in this case, minus 5 here, it's going to be 3 times your alpha plus beta, your two roots. And it'll give us minus 5. Now, from here, we can say that from both equations, alpha beta, for the first one, if you divide it by 3, equals 4/3. And for the second one, alpha plus beta equals minus 5 over 3. We could solve this, and get individual results. That's cool too. But let's just leave it like this for a second here, because we can solve this quite fast. Now, since we showed you how to do the first one, let's try the second one, guys, yeah? So it's literally the same equation, but the only difference is we need to form a quadratic equation. So let's call this quadratic equation, I'm going to change the letters here, so I'll use capital letters. So capital AX squared plus capital BX plus C equals 0. Now we need to work out what A, B, and C is. And we know part of the solutions. We know that it has these two roots here. And the first one had these two roots. So let's copy the idea, yeah? So using the same method here, let's say, like just how we're able to find 4, let's say to get capital C now. So to get C, we just have to do, again, the first term, so it'll be capital A times your two roots. So our two roots are these two terms, so it'll be alpha plus 1 over 2 beta times beta plus 1 over 2 alpha. And again, this is supposed to give us a solution of C, yeah? Now, all you have to do is just expand the bracket here. So therefore, we're going to have, let's see. Let's have a look. So alpha times beta is alpha beta. Alpha times 1 over 2 alpha. So that's alpha over 2 alpha. So basically, alphas cancel out. You got half. Next one, beta times 1 over 2 beta. That's just 1 over 2. And lastly, 1 over 2 beta times 1 over 2 alpha. That's actually 1 over 4 alpha beta. Cool. That's supposed to equal C. Now the good thing here, guys, yeah, is that you don't actually need to, again, work out these terms individually. We can use the results from the first part. We know alpha beta equals 4/3, yeah? So let's replace this one with 4/3 and that one with 4/3. So now we have A bracket 4/3 plus, well, a half plus a half is 1 whole, plus, so 1 over 4 times that. So 1 over 4 times 4 over 3. And again, that all equals C. Now, what you could do, because there's a calculator test, you could put all of this in your calculator. And if you do that, you should get a result of 121 over 48, yeah? So take your time, guys. Put this in a calculator, see if you can get that result. Now you got this result, you can say, therefore, you're going to have A times that coefficient. So it'll be 121 over 48A, and that equals C. So we'll leave this one here. So we found a C so far. Now, let's try and find the second term. So just like how we found minus 5, let's find B. So we can say to get, let me go down a bit, to get B, using the same idea, previously when we found the second middle one, we had to add up the two roots and times against the first term 3. So in this case, we're going to add up these roots and times against A. So it'd be, in this case, big A, and then we're going to add up the two roots. The two roots were alpha plus 1 over 2 beta plus, and the other second root was beta plus 1 over 2 alpha, and that's supposed to equal b, guys. Now, what we could do, we can just rearrange this order, yeah? Because we know from the solutions that alpha plus beta is minus 5 over 3, so we can add this up. Alpha plus beta is minus 5 over 3, so we've got a bracket minus 5 over 3 plus. Now, for these two terms, what we can do, we can just combine them and make sure they have common denominators, yeah? So one has beta, one has alpha. What we can do, we can times up and down here by alpha, and times up and down here by beta, yeah? If you do that, you can have alpha over 2 alpha beta. So we know basically both of them would be over 2 alpha beta, yeah? The first one, this would be alpha. And the second term, this would be beta. Cool. And now all of this, again, is supposed to equal capital B. So guys, one thing to be careful here. Try not to mix up your betas and your b's, or if you're using little lowercase letters, try not to mix your little a with your alpha. Now, final part here, guys, yeah? So now we can update the results. So we've got minus 5 over 3. We know what alpha plus beta is. It's just, again, minus 5 over 3 in the top line. On the second line is 2 times alpha beta. Alpha beta, we said previously, is 4/3. So this would be 2 times 4 over 3. Cool. And that's going to equal b. Now, again, put all of this in your calculator. I'm not going to lie, guys. This is a lot of steps in it. So put this in your calculator, and what did I get? And I got minus 55 over 24. Don't worry if the answers are slightly different to the mark scheme, yeah? Because the final result will be the same. I was going through this a couple times. Now, because that's minus 55 over 24, again, so that means the final solution for this part would be minus 55 over 24 times a, and that gives us our b. Finally, guys, now we can wrap this up here. So we found our c, we found our b. We're going to go ahead and update this quadratic equation now with our results. So just quick key reminder, yeah? Our c result was here. So c was 121 over 48a, and b was over here. That means our quadratic equation is now ax squared plus, well not plus, it won't be bx, it will be minus 55 over 24ax plus, and our c value we said was 121 over 48a. So plus 100 over 21 over 48a equals 0. Cool. Almost done, guys, yeah? So one final step. 2 steps, actually. So because they all have a's, you can just divide a across so that it disappears. And now, in the beginning of the question, this would usually be the end, yeah? But they said, without solving an equation, form a quadratic equation with integer coefficients. So in other words, you got to make sure that your final results are all whole numbers, yeah? Not fractions. Now, numbers, let's just clear the fraction, yeah? So let's times everything by, let's see, 48. Because we know this is like a factor of 48. So times in 48 through, you should get a final answer of 48x squared minus, well, 55 over 24 times 48 is 110x plus the last one, 121 equals 0. And that's it, guys. We've done it.